Welcome to this tutorial series called Zero to Autonomous in FRC Java. We will be discussing topics from simply turning a motor to some common autonomous driving algorithms using PID, motion profiling, and pure pursuit. Along the way, we will also talk about state space control. Before starting this tutorial, you'll need some basic knowledge of programming and the Java language, a FRC coding environment including VS Code and FRC driver station, and a practice robot where you can test your code on. Today, we will be writing the robot code for the standard AnyMode chassis for both teleoperated mode and autonomous mode. For the teleoperated drive code, we will be using arcade drive, spark motor controllers, and a standard joystick. The autonomous program will be able to cross the auto line using the timer class in the WPI library. First, let's create a new robot project. We will be using a template called Time Skeleton Advanced because it's easier to understand. Then, let's put this project into a folder, give it a name, and specify your team number. On the left is the project folder. All the robot code is going to go inside the FRC folder. We will first look at the file robot.java. Without doing anything, the template generates some functions for us in this file. There are two types of functions: initializing functions and periodic functions. Initializing functions are called once when the mode is starting. Periodic functions are called repeatedly 0.02 seconds to update the commands running on the robot. In different periods of a match, different modes will be called. But before we dive into the code, let's look at what exactly happens on the robot when we control a motor. For us to control a motor, we need to use something called a motor controller. From the code, we can send a PWM signal to the motor controller telling it how fast we want to spin our motor, and the motor controller will translate that signal into a voltage output to the motor. To send the PWM signal, we need to use a class in the WPI library called Spark. We will make this a private global variable, calling it leftMotor1. The 0 represents PWM port 0 on the Roborio. Then, let's create 3 more motors. Now, we will set the speed of the motors in the teleoperated periodic function. In the parameter, 1 means full speed forwards, -1 means full speed backwards, 0 means stop, and we will put 0.5 for now. Because the right motors are on the opposite side of the chassis, they need to spin backwards if we want the left and right wheels to spin in the same direction. At this point, if we were to run the code, the robot would go forward forever. The next step is to have it respond to a joystick input. Here, we will use a type of joystick layout called arcade drive. We want the left joystick to control power and the right joystick to control turning. And for us to use a joystick on the robot, we need to plug it into the driver station computer. The computer will then send the joystick signal to the Roborio. To find the axes on the joystick, we need to specify 2 numbers: the joystick port number and the axis number. We can see what they are by going to the 4th tab in the driver station. The joystick number tells the computer which joystick we're talking about, and the axis number tells the computer which axis we want to use. In this case, power is axis 1 and turning is axis 4. In the code, we will create a new joystick called Joy1 and let it equal to the joystick on port 0. Then, in teleoperiodic, we are going to repeatedly read the status of the axes. To do this, we will reference the joystick that we have created and use the getRawAxes command. Based on the desired speed and turn, we now need to calculate the power output to the left and right side of the chassis. With arcade drive, it basically goes like this: left power equals speed plus turn, right power equals speed minus turn. Now pause and ponder this for a moment. Think about how the turning factor results in the left and right power differences and how that makes the robot turn. Finally, we will output the calculated left and right powers to the motors. And we're done! Let's bring it outside and see if it works. Finally, let's create the autonomous code that crosses the auto line. The plan is to drive forward at 60% speed for 3 seconds. We will only be using a timer. In the code, let's first copy the set motor commands into autonomous periodic. In here, we will be monitoring the time. If time is less than 3 seconds, then 60% speed, otherwise stop the motors. One thing to note is that the timer starts counting as soon as we turn the robot on, not when we start autonomous mode. If we want the elapsed time since we have started the autonomous mode, we need to store the time when autonomous mode started. To do this, let's create a global variable called start time and assign the time to it in autonomous init. Now, when we are checking for the elapsed time since autonomous mode has started, we can subtract the current time by the start time. And then the code is finished. Let's take it outside and see how it works. Thank you for watching this video of 0 to Autonomous in FRC Java. If you find this video helpful, your friends might too. So please like or subscribe, and tell your friends about it. Again, all this code is available on GitHub, the link is in the description below. And if this code didn't work for you, or if you have any questions, please send me an email. Until next time, happy coding.